Hello guys, welcome back to this video where now we're talking about, actually it's not welcome back because it's the first time you check it out, but if you're checking it the second time, welcome back. So welcome back to my channel. Let me say, today we're going to talk about exponential functions, of course, and as per usual we're going to start with grade 10, what you guys did, and then we're going to go forward in terms of now what we have for grade 11. You know what I'm saying? Yeah, so already we have this, already we have this grade 10 form, where it's a, it's a, this a multiplied by b to the power of x. Notice that the x here is an exponent, Yeah, so yeah. So I mean, I know you guys are gonna get this right. I know you're not gonna mess it up. Yeah, but because you can have like powers. One of them is like, say, okay, I think, yeah, for now, for grade 11, we have two functions that have exponents. It's parabola and exponential. But for parabola, the x is the base, Yeah, I'm just gonna write it here for for parabola, x is your base, not the exponent. So you have x squared plus whatsoever. And then as for the exponential, right, the x is the exponent. Yeah, I think that's why they even call it exponential, because the x is the exponent. As you see here, the x is the exponent. So yeah, I mean, yeah, cool. So also grade 10, we had this thing called q. It's a b to the power of x plus q, and b was greater than 0, because b had to be greater than 0. So now the thing is, if we look at q, right, let's look at q. What do you think q is for? We have done like parabola. If you think about parabola, what q was, and you think about hyperbola and what q was, you can easily say, q here is gonna be the vertical shift, and you are right. So our q represent the vertical shift. Yeah, and we've also spoke about this thing called asymptotes. In this case, for exponential, we only have one asymptote. Remember, in hyperbola we had two, but here we have one asymptote. And yeah, it's gonna be the horizontal asymptote, right? So now, if q is 0, then you know that your asymptote, your horizontal asymptote is what? Is your x-axis, right? Yeah, if q is 0. But if q is positive, then you know your graph, it shifted q units above, from the origin, or in fact the function shifts 3 units upwards, and your as well as your horizontal asymptote is gonna shift 3 units upwards, right? And if it's q is negative, then it's gonna shift q units downwards, both the graph and the asymptote as well, right? So let's go on and talk about the shape of this thing. Let's go on. So of course, I mean, both a and b, right, I did highlight here. Both a and b, they tell us about the shape, right? They tell us about the shape. So we're gonna maybe talk about how, they tell us about the shape. Yeah, but not so true. And there are effects of a, there are effects of b, but now let's focus on a. Let's focus on a. And this thing is very simple. You see, it's very simple. So if a is greater than 0, a is positive. So you already know that the graph, your function, is going to be above the asymptote. I'll make an example. So this right here, we have our function, and say the asymptote right here is, right, this is the asymptote, right? And let me just name it q, and name these ones x-axis, y-axis. Sure. And now we have our graph. Now, it doesn't matter what the graph looks like, it's going to be above. Like, say our graph is a positive graph, it's gonna be something like this. Above the the asymptote, or maybe if it's negative, it's gonna be something like this. Yeah, but the thing is, our graph is above the asymptote. This right here, the Q, this right there is the asymptote, and if a is greater than 0, then we know our graph is above that asymptote. And then we go for a being smaller than 0, meaning that a is negative. Then in that case, your graph, ne, I'll just make it here. Your graph is going to be below, so of course this is your y-axis, this is your x-axis. Say for example, this is my first asymptote. With that asymptote, my graph is gonna be either like this, we have one, or it's gonna be like this. We have one. You see that, ne? Fair. So these are things that, yeah. So we're still gonna go in deep as to what is what. But just know this: if a is positive, the function is above the asymptote. Is a is negative, the function is below the asymptote. Ne? And let me make another example. Let me delete this. Ne? I've deleted those things. And say, for example, that my asymptote is right here. Say my q is a negative value, right? An example, q is close to -3. Then a is smaller than and a is smaller than 0. Then I know my graph is gonna be what? It's gonna be below my asymptote, right? So I'm gonna have the first function looking something like this, right? And of course this is gonna go that way. And the second one, the second possible one, is gonna look something like this, right? Yeah, you know what I'm saying. And also, even here, let's go back to this function right here. Né? If I put my asymptote and said, look, perhaps I have an asymptote here, and with that asymptote, it is stated that a is positive, my graph is gonna be above the asymptote. That's, yeah, just know that, né? Yeah, so this thing, I don't think you guys get tested on if a is positive, what happens to the graph. But these things, they help you, because you want to save much more time when you're writing the exam. You want to save much more time, so these things, they help you a lot. At the moment you see a graph, you already know, oh, so my a is negative here. So in your calculation, if you were ever to be asked to find the equation of that graph, you know that a has to be negative, because a is what, because the function seems to be below the asymptote. But then if the function is above the asymptote, it doesn't make sense that your a is going to be what? It's going to be negative. So once you know all of those things, it even helps you to be more accurate, because sometimes we can make mistakes and we are not aware that we are making mistakes. We feel like the calculations are flowing, everything is just flowing nicely, and the only thing that helps us maybe get more marks is the negative marking, where like on question number 1 you make the wrong calculation, and then question number 2 you continue based on the answers you got from A, which of course were from wrong calculations. Some of the markers that have been stated that you will be granted marks because you used the previous answer, even though it was wrong whatsoever. But you want to eliminate as much mistakes as it can. So make sure that you stay with me here, ne? We're gonna get to the deep stuff. Just hold on. Sure, let's talk about B. We have spoken about A, ne? So B, what do we know about B right now? We're still in grade 10, ne? What we know about B is that B can never be what? B cannot never be negative or even 0, because if B is 0, look, so say I have a y equals to a b to the power of x plus q. If b is 0, I have 0 to the power of x, which is 1. So that means this is gonna be a plus q, and it's not a function, because I only have what? This is not a function because I'm only gonna have y equals to a particular value, say k, right? Because when I add this and I add this, I'm gonna get a constant, you see. So I'm gonna get like this, y equals to k, and so forth. So we already know that b can never be 0 and b cannot be negative, right? So what happens is that b can hold on two possible values, is the values above 1 and the values between 0 and 1. So we're gonna talk about that, ne? So now what if b is greater than 1, ne? Okay, so do realize, ne, guys, do realize that for both these examples, our b is greater than 1. So the only thing that's different here is the a. Yeah, the a is the only thing that's different. We have one where a is positive, one where a is negative. And yeah, so basically here we're trying to find the effects of b being greater than 0, when a is positive. So here both a and b are positive, of course, but then b is greater than 0. What does that mean? We have an increasing function. And what does that looks like, ne? Let's go back. We draw our Cartesian plane, and of course you have y-axis, you have x-axis. A is positive, right? So a being positive, let's say q is right here. This is q, right? This is q, right? Which is the what? Which is the asymptote. And then because a is positive, we know that our graph is gonna be what? It's gonna be above the asymptote, and our graph is either gonna be like this or it's gonna be like this, but whatever the graph is, it's above the asymptote, which is what we're gonna have here. So now they say we have an increasing function, eh? So how I think of increasing and decreasing is like, so we draw this, Cartesian plane. This is y-axis, x-axis, this right here, ne? This, right, it's an increasing function, right? And any function that is shaped in this manner, you could have, a function that is like this. You could have a function that is like, this, any function that is shaped in this direction, that follows this direction. You see that as the x value increases, ne, the y values, they also increases. When you are here, both y values and x values are smaller than when you are here. Both of them are bigger, right? So that's what we mean by an increasing function, right? And as for decreasing function, it's gonna be the opposite, ne? The opposite, by it's gonna be something like this. Look at this. As the x value increases, the y values decreases, ne? For example, here I have a high x value and a low y value, but when I get here I have a low x value and a high y value. So this is a decreasing function, and anything that will follow this path, we could have a function that like this, or we could have another function like this. These are all decreasing function, eh? So you have the idea, you have the shape. So let's now go back. We say it's an increasing function. So since we know that exponential function is either like this or like this, sometimes like this, sometimes like this, we know these are the kind of shapes. So for something that is positive, that is increasing, an increasing function, I'm expecting it to be like this. All right. So, and then of course here we're going this way while not touching the asymptote. So your function is gonna look something like this. Because it follows that that straight line of an increasing function. If you have your Cartesian plane here, there's an increasing function and what it looks like. So yeah, and let me not erase that. You see, cool. Now number 2, we have when a is now, remember b is still greater than 1, eh? But what's the difference now? A is still greater than 1, yes, but no, b is still greater than 1, but a is now negative, ne? So let's have our asymptote right here. This is our asymptote q. So now for a being smaller than 0, we know that our graph, whatever it is, ne, our graph is gonna be what? It's gonna be below the asymptote. So now with the b being greater than 1, of course, we're gonna have a decreasing function, and a decreasing function is something that follows this direction. So that means that my function is gonna look something like this. You see? My function my exponential function is going to look something like this. And right here we have what? We have our decreasing exponential function, right? Very easy, very straightforward. Like I was saying, you know these things. When you are writing an exam, it's easy for you to just see whether you have an equation. From an equation you already see b is greater than 1, a is negative, so I know because a is negative, I have my function is below the asymptote, and since b is greater than 1, I have a decreasing function, you see. So man, there's just once know this thing, guys, know this thing. They're very, very important. Cool, let's go. Now remember I said there are two possible values for b. It's b being greater than 0. No. Yes, I mean I'm right, I'm not wrong, but I want to say it's b being greater than 1 and b being between 0 and 1. And also do notice that b cannot be 1, because when you have 1 to the power of x, so true. I think there's this rule that says 1 to the power of anything is 1, right? 1 to the power of 0, 1 to the power of -1, 1 to the power of I don't know, anything. One, yeah, there's that rule that says 1 to the power of anything is just 1. So, and we're gonna end up with the same a plus x, then we have y is cos to k. Yeah, but man, this is nice. This is nice. So we have now b is between 0 and 1, ne? And I will say it again. Do notice that for both first point and the second point, we have the same values of b. The only thing that's different is the a values, right? So it, yeah. So now we have our function, and the question now is like, we are here, number 1, a is positive. So when a is positive, look, for since there my asymptotes were above the x-axis, let me here maybe put them below the x-axis, different color. Let me do this. Okay, so we have this now, and what do we have? A is positive, ne? Yeah, a is positive. I'm even realizing that I'm gonna need to redraw this graph, because when a is positive, what's happening? Our asymptote is what? Our graph, not our asymptote. Our graph is gonna be above the asymptote, ne? Yeah, so I will have to take this down. Yeah, so yeah, and then my asymptote is still below. Right, so x-axis, y-axis, and then this is my q, right? So we talk about a being positive. We know that our graph is above what? Is above the x-axis. No, why do I lie? Our graph is above the asymptote because a is positive. So now what's going to happen to the function is going to be a decreasing function, and remember, decreasing, increasing, right? So in that case my graph is going to be something like this, right? You see, it's above the asymptote and it's a decreasing exponential function. All right, that's just it, right? And when we go and talk about a being negative, we have the opposite, ne? So we have the opposite. Now maybe for this one I can do this. Mara, do I need to? Yes, you do. No, I don't need to. Yeah, I don't need to. So and I'll have my asymptote being negative as well. So of course this is now q, y-axis, x-axis. So the question is, a is negative, that means my graph is below the asymptote, and with b being between 0 and 1, I'm going to have an increasing function. And what does an increasing function looks like? It's going to look something like this. Wish I would have used a different color, but yeah, we can work with this. It's gonna look something like this. So we have different shapes now of exponential functions, and guys, just know these things, man. These things are just when I spent almost 20 minutes talking about them. And I'm sure these things, they're gonna help you a lot. Yeah, really, they're gonna help you a lot. That was fun. I don't know, I also had fun explaining them. Now let's go back to the grade 11 stuff. Now yeah, man, let's talk about grade 11. Grade 11, we have something new, right? I see here I wrote, what do you think the effects of P are? And these things like parabola, exponentially, hyperbola, these things, there's like some commonality between all of them, because the P, we have one of these. Okay, there's a specific manner in which you can define a P value for parabola, hyperbola, and exponential, right? But then there's that one definition that fits them all, which is what? P represent the horizontal shift. Ne? Remember, we did say that the Q is for the vertical shift, but P is the horizontal shift. And if you go back, we know that specifically for parabola, P is the x value. Okay, minus P is the x value of what? Is the x value of the turning point of the parabola, right? And yes, it is the responsible. It is also responsible for the vertical shift, right? No, the horizontal shift. We go to a hyperbola, we talk about, yes, even though P is responsible for the horizontal shift, it is also the what? It is also the vertical asymptote. You see, and now we go on and talk about exponential. We say, what about exponential? We see for parabola, it's a minus P is an x value for the turning point. That's what's specific to parabola only. When you go back to hyperbola, now hyperbola is the vertical asymptote. What about P in exponential? Is it just horizontal shift, or is there anything else? But fortunately or unfortunately, I don't know. Fortunately or unfortunately, here it's what? It's just only horizontal shift. Nothing really complicated about these matters. Yeah, but it's gonna be the what? It's gonna be the horizontal shift. Yes. Right, so you can write that down. Okay, P is just a horizontal shift. And by looking at this graph, remember initially we had A, B, X plus Q. I need to warn you guys, it's just yeah. So it's raining outside, but now it's not raining. So it's on and off. So I'm gonna try to speak as loud as I can. The moment it starts raining, like just now, I can hear a few drops. So yeah, man, I hope the rain won't affect the video. So let's go back. Grade 10, we had this thing where we had only x plus 0. It was just a b to the power of x. And the thing is, for b to the power of x, we don't have anything. It's just b to the power of x. But now for grade 11, we have b to the power of x plus q. That means what? That means our graph has either now shifted horizontally to the left or to the right, depending on the value of p. One thing that will always be the same is that, when you see negative, your graph went to the right. When you see positive, your graph shifted where? To the left. Let's go and cook, man. Let's go and cook. Man, I don't know, like I don't know if it's just today or maybe I'm just feeling this lesson, and it's starting to rain as well, so I hope this won't affect the video. But yeah, let's talk about the range and the domain. Range and domain. So as for the range and the domain, we talk about, we have already discussed what they are, so we know what they are. So yeah, now let's go for domain. For domain, what is the domain of an exponential? Let's go back to the graph that we did draw. We drew these graphs. I could say perhaps I will use this. This is graph number 1, graph number 2, graph number 3, graph number 4. All these 4 graphs, these are possible shapes that your exponential are gonna take. And when you look at them, what do you think is happening to the x values? So of course here we see that we're going to the negative infinity. Even here, we're going to the negative infinity, right? And then here, this, it's gonna continue. So in terms of x values, the x values, they will also continue to the positive infinity, right? The same is true with this number 3 and 4. Number 4, you see we're going to positive infinity here, positive infinity here. And you also know that like this graph is gonna go further and further and further to the left. Also here it's gonna go further and further and further to the left. So we already see that what the domain here, x will just be an element of real numbers, right? Yeah, well, or you can say x it's gonna be between negative infinity to positive infinity, just like that. This is the domain for exponential, just like that. But as for range, what's gonna tell us about the range is what? It's a and q, right? So for a, you look at the sign. Maybe let me write this down. For a, you look at the what? The sign. And then for q, you look at the what? You look at the value. Those two things, they're gonna tell us what our range is gonna be. They're gonna tell us what our range is gonna be. Let's go back. When we look here, remember, okay. So here a is positive, and when we have q here, so we see that our graph for a, if a is positive, we moved from q not included to what? To positive infinity, because it continues like this. It just continues going up like this, and also here a is positive. So let's go. We have q here, so we see we are moving from q, and from q we're going up up to positive infinity, right? You see that. Let's go now to where a is negative. So here a is negative. We see we move from q to where? To negative infinity. That means we're from negative infinity all to q. We have one. And the same is true also with this one. We moved from q and we went downwards with the y value. So that means we are coming from negative infinity to q. So you see that there are two possible ranges depending on your a. Yeah, but I can just say, maybe make some big space and say, yeah, if a is greater than 0, a being greater than 0, your function is above the thing. So you're gonna have y being what? Y being greater than q. This is your range. And then if a is smaller than 0, then y is smaller than q. This is your range, right? Or alternatively, I'll use a different color. Alternatively, you can say here from q to positive infinity, or from negative infinity to whatever the value of q is, right? Yeah, man. Let's put this in practice now. So we have these two functions. We're gonna give the domain, the range, whatsoever. Yeah, let's cook. What's the domain? I mean, the domain is just easy, guys. So I'm just gonna leave it at x is an element of real numbers. Yeah, when x is an element of real numbers, and me saying x is an element of real numbers, I'm just saying there's no point in this function where x is not defined. You see? Yeah. And as for range, what do I look for? I look for my a, and I see here my a. Remember, b will always be positive, so if I see a negative before the base of my the base that has an exponent, I know that negative sign is a, just like here. So my a is negative. Where are we? We are here, where a is negative. So we already know that we look for q. What is q? Q is 1. So therefore my range here, I can say q is smaller than, sorry, y, sorry for that, y, it's smaller than 1, right? Or perhaps this is my range. I could say y is an element of real numbers from real numbers. Yeah, one from where? From negative infinity to 1, right? And yeah, I'm done with the domain and the range. I don't know, let me just finish up this one. I'm now finding the x-intercept. Remember, x-intercept, y equals to 0, so that means I'm gonna have 0, -5, minus 2 plus 1. Okay. Yeah, now I forgot where I was. So my mom just came in and then I just paused the video for a couple of minutes, but let's cook. Oh, we're solving this. It's just simple maths here. So for x and yana, let me remove this because it sort of disturbed me here. It's x to the power of, this is minus 2. Right, I don't know if you want to do this, but let me just give it to you if you may want to do it. Now you could say you have, maybe let me take that minus 1, the one I took it to the other end. You could say you have minus 5 to the power of x multiply by 5 to the power of minus 2, right? Remember this a, this negative is what? Remember that negative that we see here, this is a, it's not b, so that's why I don't have minus b here. I'm very thankful that I did that, because yeah, this is very important. Yeah, but just laws of exponents. But it can be confusing because yeah, this thing here, it's negative a, it's my a here, my a in this example, a is close to negative 1. Yeah, man. So and b is always positive, so that's why I have b, like that's why I have 5 to the power of minus 2. That's why I have 5. Yeah man, let me cook. And also now I know that 5 to the power of minus 2 is 1 over 5 squared, which is 1 over 25, ne? So I'm gonna write it like that. Yeah, when I just wanna, you see I don't have enough space there, so let me just do it this way, ne? Cool. So now I have negative both sides. I'm just gonna divide by negative. Yeah, or perhaps let me do this, ne? Let me multiply everything by negative 25, and when I do that, I have 25 here, I have 5 to the power of x. You see, exactly. Yeah, and then this is just gonna cancel out. Yeah, and then of course here this is 5 squared is equals to 5 to the power of x, and therefore x is equals to 2, and therefore I have x, I have 2 and 0 being my x-intercepts, right? Cool. This was fun. The y-intercept, remember y-intercept, x is equals to 0, so now I go y is equals to minus 5 to the power of 0 minus 2, ne, plus 1. So this is just a number. Yeah, when it's minus 5 to the power of minus 2 plus 1, which is minus 1 over 25 plus 25 over 25. Yeah, so which is gonna be, it's gonna be what? It's gonna be 24 over 25, right? So I could say therefore you have 0 and 24 over 25. Correct me if I'm wrong here, you just press in the calculator to get the right number. Yeah, so and as for the asymptote, my asymptote is gonna be y is equals to q, which is equals to 1. This is my horizontal asymptote. Let me go here a is positive, so I'm gonna have for range, I'm gonna have y being greater than what? Y being greater than q, which is minus 1, right? Or alternatively I can just say from negative infinity, no, I'm lying, I can say from negative 1 to positive infinity. Yeah, x-intercept y equals to 0, so now I have, ooh, wait, I didn't see this. Wait. So, do you realize that, hey, let me erase this, ne? Do you realize that we have y all over 2 equals to 3 x minus 1 minus 1. We have to multiply by this minus 2 so that we have y equals to something, ne? So let's do that. We multiply by 2, and it's gonna be y. It's gonna be 2 times 3 to the power of x minus 1, and this is gonna be minus 2. And what does that mean? It means this is our q, not 1, and therefore our range here y is greater than what? Is greater than minus 2. or minus 2. We're from minus 2 to positive infinity. This is our range, you know. Yeah, yes. Oh my god, I didn't see that. Dang. Right, so yeah, let's cook. Let's go on. Now x-intercept y is equals to 0. So x-intercept y equals to 0, we can just say 0 over 2 equals to 3x minus 1 minus 1. So I have 0. I'm gonna have 0 this side. I'm gonna have 0 this side. This is 0, right? And I'm gonna take this minus 1 to the other side of the equal sign. So I have minus 1 equals to 3 to the power of x multiply by 3 to the power of minus 1, which this 3 to the power of minus 1 is the same as 1 over 3, ne? So I'm gonna write 1 over 3 here. Then the next step, I multiply by 3 all over. Oh shit, look, this, I have negative 1, so there's no way it's gonna come here negative. It has to be positive. So now I multiply by 3 both sides. I have 3 on this side equals to 3x, and therefore x equals to 1, and therefore I have 1 and 0. These are my x-intercept. Y-intercept, x is equals to 0, so y over 2 equals to 3 to the power of 0 minus 1 minus 1. So I have y over 2, I have 1 over 3 minus 1, or maybe minus 3 over 3, and wait, yep, so we do that. I can, yeah, and I don't like doing this thing that I'm doing, but I'm just doing it because of space here. So 1 over 3 minus 3 over 3, it's gonna give me minus 2 over 3, ne? So here I have minus 2 over 3, ne? So let me write it down. Go green. Y over 2 minus 2 over 3. Now I multiply by 2 all over. If I multiply by 2, then I have y equals to minus 4 over 3, and therefore I have 0 and minus 4 over 3 as my y asymptote. No, as my y-axis. So help me out, guys, if I did anything wrong, but I doubt I did. But if I do, because I did get some stuff wrong some other time, so just bear with me and give me a hint. Here for the y-intercept, it's gonna be y equals to q, which is minus 2, and then we are done with all these calculations here. Yeah, so now we're just gonna sketch both graphs. We're gonna sketch both graphs, and then we'll be done with this section, I believe. So let me see. Yes, we'll be done. Then the next section is trigonometric functions. Right, so we're gonna graph these problems, ne? And yeah, so I mean, at least we have already calculated we know the range. It's not necessarily going to help us, but I just thought of putting it there, the domain from negative infinity to positive infinity. So yeah, it's not going to help us at all. I mean, yeah, it's not going to help us, I think, with help plotting the graphs, but probably it is, but not so much, but it is. We have our x-intercepts, y-intercepts. So these are the kind of things that you would calculate, you know. These are the kind of things you'd calculate when you're trying to sketch your exponential graph. You must make sure that they're there. And we will do step by step how, you would draw these graphs. So let me go on, start our Cartesian plane. Yeah. I always wonder, like, what if this thing Cartesian plane you're pronouncing it wrong? Because sometimes I just say, I don't know, Cartesian plane or plane. But I could. So this is right. These arrows are just important just to show that these lines are just going up, down, left, right, you know what I'm saying, x-axis, y-axis. We have it. Ne? You have your graph. Now the second thing is put down your asymptote, right? Put down your asymptote. I'll use this color red. Say this is q equals to 1, right? So q equals to 1, and now let's talk about this. What is the sign of your a? Our a, I love this thing so much, bro. Our a is what? Is negative, ne? What does that mean? A being negative implies that our graph is going to be below the asymptote, ne? So by it being below the asymptote, it's gonna be something like this. Of course, if this is the asymptote, our graph is gonna be either this way or this way. But yeah, we did talk much about that. Now we have a question of, is it going to be an increasing function or a decreasing function? We look at b now to answer that question. B is greater than 1, right? Remember, b can be between 0 and 1, or it can be greater than 1. But in this case, b is greater than 1. So if b is greater than 1, a is negative. What does that mean? It is a decreasing function, not an increasing function. So yeah, we already know our graph is going to be below the... yeah, it's going to be below the asymptote, and it's a decreasing function. So it probably gonna be something looking like this. But let's put down the x-axis and the y-axis. X-axis we have 2 and 0, so I'm guessing that will be somewhere here. I can say this is 2 and 0. Y-axis we have 0. Yeah, let me get the calculator. Right, so with the calculator, I'm just gonna put 24 divided by 25. I'm sure it's gonna be 0.9 something, 0.96, which is gonna be, say, somewhere here, right? This is 0 and 24 over 25, which of course is, from the calculator here we see 0.96. But yeah, and these are the very important points. So now with this, I already know that it's a decreasing function. That means the shape is something like this, right? And it's gonna be below the asymptote. So this is the asymptote. Our graph is gonna be below here. That means our graph will be something like this. Beautiful. And it just goes down and down and down like this. And right, and of course, I mean, I'm just gonna say not drawn up to scale, but just make sure that the graph does passes through those points. And I will say one thing that is very important. I think there's a 1 mark for this, ne? Yeah, I think there's a 1 mark for this. So it's an extra point. So just put an extra point on your thing, on your graph, right? So here I'm just gonna put to the power of, I'll say x is 5, so 5 minus 2, right? And plus 1. Yeah, that's a lot of number. Maybe let me just go for, I don't know, 2. Yeah, 2 seems to be... oh damn, oh yeah, 2 is the... I forgot 2 is the x-intercept. Yeah, 2 is the x-intercept. So perhaps let me go for 3. Yeah, oh, okay. If x is close to 3, then y is gonna be minus 4. Right, so I can just say that this right here, this is 3 and minus 4. And there we go. You have the asymptote, you have x and y intercept, and of course the range is from 1 to negative infinity. You know, everything is perfect. Everything is perfect. Your shape is perfect. You know, it's a decreasing function. You know, you're good to go. And let's do this one. So It may be right more when the day is awakening, when sorrow through darkness and dear. So I'll put my asymptote, which is -2 here. I'll say this is -2, q equals to -2, and yeah, let me just put my x intercept. It's gonna be here. This is 1 and 0. I think this is here. So here it's this is 1 and 1.333, I believe. Let me see. -4/3. Yeah, it should be 1.333 -1. So this is, say this is minus, this is -1, and right here this is -1.33333. So I'll just write it down as -4/3, right? I mean, from just low key, I'm gonna say this now, from putting my x-intercept and my y-intercept, low key, it seems like you kind of do not have to bother yourself about the shape, because I mean, the only shape that kind of makes sense right now is your graph going like this. It's your graph going like this. But let's go through it logically. Ne? Our a is what? Our a is positive. Remember this function, ne? This is the function. We multiply by 2, we end up with something like this. Y is equals to 2 multiplied by 3 to the power of x minus 1 minus 2. This is what our function looks like. Our a is greater than 2, right? Our a is greater than 2. What am I saying? Our a is greater than 1, and it's positive. And b is also... Damn, okay, look, we don't care whether a is greater than 2 or a is greater than 1. We don't care. What we care about a is just the sign. So, yeah, so a is positive. We have positive 2. And b, that's where we care about greater than. B is greater than 1. So that means our graph is going to be what? Because of the positive a, our graph is above the asymptote. And because of that, b being greater than 1, it's an increasing function. So it's gonna be something like let me use a different color. So it's gonna be something like this and this, and we just go up, just go down like this. And you can just like put an extra point on your function just to see what value you get. So maybe 2 times 3 to the power of let me say 2 minus 1, then minus 2, right? So if x is equals to 2, then I'm getting 4, right? So that means, say for example here, this is okay, maybe that will be here, x equals to 2. So then this point here is your extra point, which is what? Which is 2 and 4. And then you have your asymptote, you have your intercepts, and you have an extra point. Perhaps one missing thing, y-axis, x-axis. Now just put the arrows, and just like that, you are done. Our graph is perfect. Basically, yeah, you are done. Graph looks perfect, everything looks fine, right? Yeah, so just know this thing, man. And yeah, I hope this video was very helpful to you. In the next video, we're gonna do cosine and sine function. So we'll be doing with cos and sine, at the same time, simultaneously. So good luck, and I'll see you in the next video.